So here's two examples where the launch is horizontal. First, calculate the velocity after 2 seconds of an arrow that is fired horizontally with a velocity of 90 meters per second. So I told you that we're going to do this by setting up two problems basically linked by time. So I'm going to be working vertically, and upwards will be positive, and horizontally. Do I need to draw a diagram? The arrow is going to be fired horizontally this way. It's going to go like that. So the thing is, it's going to be launched with horizontal velocity this way. Should have been horizontal exactly, of 90 meters per second. Now when it comes over here, it still has a horizontal velocity that's the same, 90 meters per second. But its vertical velocity, it's now been accelerating downwards for 2 seconds under gravity. So, vertically and horizontally. And the key is the time is the same. It's 2 seconds for both horizontal and vertical. So horizontal, it was 90 meters per second. The acceleration is 0 horizontally because we're ignoring any air resistance. What else do I know? Oh, the final velocity is also 90 meters per second. It's constant speed. It's actually easy. I don't even need to do this for this problem. I need to work out the final velocity. I've got the final velocity already, horizontally. But vertically is different. It starts horizontal, so there's no initial horizontal velocity. I need to work out the final there's no initial vertical velocity. I need to work out the final vertical velocity. The acceleration is gravity. It's negative because by our convention, up is positive. I actually don't care about displacement for this question. So, vertically, can I work out the velocity? U, V, A and T. So that's V equals U plus AT. U was 0, negative 9.8 times 2, which is negative 19.6 meters per second. So horizontally, my final velocity is 90 across. Vertically, it's 19.6 down. To work out my actual final velocity, I need to put those together as a vector. Across 90 and vertically down 19.6. And I'm looking for this vector here. That's my final velocity. Well, its magnitude is from Pythagoras, 90 squared plus 19.6 squared. I'm not going to try and do that in my head. Square root of 90 squared plus 19.6 squared, 92.1 meters per second. And I need to know the angle. Let's get the angle of depression. Inverse tan of opposite 19.6 over adjacent 90. Make sure I'm in degrees, which I am. Inverse tan of 19.6 over 90. 12.3 degrees. So the final velocity, final velocity after 2 seconds might be a clearer way to say it. Velocity after 2 seconds is 92.1 meters per second at 12.3 degrees below horizontal. And here's another horizontal launch example. Calculate the drop of an arrow launched at a target 120 metres away if it is fired horizontally with a velocity of 160 metres per second. First we have to know what drop is. The drop is the distance from where it was launched to where it hits the target. That's the drop. So my target is here, and I'm launching it from here, and it's going to go, that's horizontal, it's actually going to go down in a parabola and hit a certain distance below. That's the drop. In our physics terms, that's the vertical displacement. So again, it's going to be launched horizontally at 160 metres per second, like the last example. It's 120 metres away, and we have to work out the drop. Okay, as before, a vertical problem and a horizontal problem linked by time. Again, horizontally there is no acceleration. 160 metres per second. I know the final velocity therefore will also be 160 metres per second. The time is what's going to link this together. What I know is the horizontal displacement is 120 metres. Okay? But for me to solve this, you'll see in a moment, I'm going to have to find the time. So, the initial velocity downwards is 0 because it's launched horizontally. Acceleration 9.8 metres per second squared. Displacement is what I have to find out. So I can't solve this problem without the time, but this time is the same as that time. Okay, these are the same. These two problems are linked by time. So the first thing I have to do to solve this is first solve the horizontal problem. How long did it take that arrow to travel 120 metres? Well, nicely, the velocities are the same. So speed is distance over time because there's no acceleration. I'm looking for the time, which therefore is the distance over the speed. So that's 120 over 160. 120 over 160. 12 over 16 will be, that's because I typed it wrong, 120 over 160 should be 3/4. Thank you. Alright. 0.75 seconds. And that time is the same time that's available for the vertical problem. And now you see, I can solve this problem. I want to use U, A, S and T. So S equals UT plus a half AT squared. U is 0, so that's nice. Negative 19.6 is half. No, it's not. That's 2A. That one half A. Negative 4.9, half of 9.8, times 0.75 squared. That number squared times 4.9, negative 2.76 metres. That arrow will drop over 120 metres by 2.76 metres.